Good morning and welcome to the latest Loctite webinar. Today we'll be looking at the assembly of plastic parts and the new trends on the market. Just a bit of housekeeping to start. All audio is managed through your device, so if you are having trouble hearing, please increase your volume. For best performance, please close all other applications such as Outlook and Microsoft Teams, and if you are working remotely, please disable any VPNs. If at any time during the presentation your audio becomes out of sync, please refresh your browser to correct this. There will be time for a short Q&A session at the end, but if you have any questions during the webinar, please put them into the Q&A box on your screen and the technical team will answer your question. If you need to leave at any point and miss the end of the webinar, you can finish the session by watching the replay on the link sent to you after the webinar, and it will also be available on our YouTube channel in the coming days. The webinar today will be led by our experienced presenters, Julie Joseph and Håkon Jakobsen. They are both experienced application engineers. Both Håkon and Julie have a background in industrial adhesives and have over 20 years experience in plastic bonding.
A variety of assembly methods are available to design and manufacturing engineers, ranging from mechanical methods, such as fasteners, to tapes, welding, and adhesives. This video will demonstrate one of the key benefits of adhesives over traditional fasteners. Shown are 3 ABS lap shears. On the bottom, the 2 pieces of ABS are joined with 1 stainless steel bolt. On the top, the 2 pieces of ABS have been joined using a Loctite instant adhesive cured for 24 hours at room temperature. As a shear load is put on this assembly, you will see that on the top, the adhesive stresses out evenly and causes less flexing of the joint. On the bottom, the bolt concentrates the stress, and so you can see a great deal of flexing and eventually failure of the ABS. This is how adhesives offer the unique benefit of even stress distribution over traditional fasteners, which translates to better aesthetics, reduced weight and complexity, and improved reliability.
Thanks, George. Welcome, everyone. And as George has said, today we're going to talk about bonding plastic parts with instant adhesives. We're going to first look at some of the traditional methods of bonding plastic parts and how you can use adhesives to bond these parts. Then we're going to look at some of the factors that we need to consider when we think about bonding with adhesives. And finally, we're going to talk about some of our innovations in plastic bondings. At the end of the session, there will be a Q&A section. So please use the Q&A section on the module and ask any questions you have. If we don't get to your question today, then we will, please email us on the technical helpline email, which will be available at the end, and we'll answer the questions. So just before we start, what we will be talking about today is bonding plastic, but we do also have instant adhesives that will bond other materials. So for instance, if you want to bond plastic to metal or plastic to ceramic or other combinations. So today, since we're speaking about plastic bonding, we're going to start with defining the different types of plastics that are out there. So probably the biggest group of plastics are the thermoplastics. These are materials which will remelt or soften as you heat them, and they are also soluble in organic solvents, which allows them to be, for instance, solvent welded. Some examples of some thermoplastics are PVC, polystyrene, and polycarbonate. The second group of plastics are thermosets, and these are materials which also have a chemical cross-link, and so they're not easily softened or remelted. But if you heat them above a certain temperature, they will start to degrade. Some examples of these types of materials are epoxy resins. And then we have elastomers. These are much weaker materials, but they're very flexible and easily stretched. They tend towards the characteristics of natural rubber. They can be swollen by solvents. And some examples of these materials are styrene butadiene resins or EPDM, for example. Thanks, George. Thanks. So when we think about different methods of assembling plastic parts, we'll think first of all about the traditional methods that are out there. So starting on the left-hand side, we've got mechanical fixings such as rivets or screws. And obviously they do join the parts, but you have to make some kind of a hole in your plastic part to be able to use the mechanical fixing. And potentially those fixings can loosen over time and vibrate. They also add weight to your part. There are tapes, but they can be time consuming to apply and they're difficult to automate. There's thermal welding, which is only possible with thermoplastic plastics. And because of the higher temperature that you're applying, it can mean that you get higher stress concentrations in certain parts of the adhesives. But on the positive side, it doesn't add any weight and the joint is almost invisible. And then we also have solvent welding. And again, this is only possible with thermoplastic plastics. It doesn't add any weight, but the disadvantages are that you have to use solvents, which have health and safety implications, and you're also making an invisible join. So overall, the challenges when you're bonding plastics are you want to avoid stress cracks, and you want to avoid getting non-uniform stress distributions across your parts. Okay, so we have a poll here to get an idea of who the audience are and what they're currently using to be able to assemble plastic parts. So if you could just let us know, how do you currently assemble your plastic parts? Thanks, George. Okay, while you're completing the poll, we'll just speak about some of the advantages of bonding plastic parts with an adhesive, and then we'll look at the results. So one of the big advantages of using an adhesive to bond plastic parts is you can join dissimilar materials. You don't have to use a thermoplastic to a thermoplastic, but also you can use very thin or fragile substrates and join that to another substrate. Adhesives also allow you to not use heavy mechanical fixing, so it can give you a weight reduction in your parts. And it gives you a virtually invisible joint because bond line thicknesses tend to be very, very thin. So this can improve the quality control that you've got, and it can lead to a cost reduction. Thanks, George. Okay, so we can see we've got a fairly good distribution. We've got some people who are already using instant adhesives, and we've got some people who are using other methods, so mechanical fixings or tapes, and a few who are solvent welding. Brilliant. Okay. Okay, so now what we're going to do is we're going to consider some of the factors that we consider when we're recommending an adhesive to be able to bond plastic parts. Thanks, George. So when we're bonding plastic parts, there's a lot of factors to consider. So we would consider, first of all, the joint design that we have. And we may want to recommend a slightly different joint design if you're moving away from a traditional method to optimize it for an adhesive bond. We would also consider the material. As we said, the adhesives give you much broader design opportunities, and also the area that is being bonded. And also the cure time. And then we would also want to consider the lifetime of the part and the environmental conditions that the bond line is going to have to withstand once it's in service. Thanks, George. Okay, so this is an example of some work that we did. A customer came to us. They had some plastic parts they wanted to bond together, and the parts were going to be used to make a signal light that was going to be used in a marine application. The parts were polycarbonate, but there were uneven gaps. So in some places there was a small gap, in other places there was a large gap. So their key challenges were that they wanted something that was going to bond but also seal on polycarbonate, was going to be able to withstand the marine environment. It was going to give a fast cure so that they didn't have to wait too long before it was going to be put into service. So the solution that we worked with them to find is we cleaned the parts first with Loctite SF7063, and then we bonded the parts together with Loctite 3090. So it's this product here. Thanks, George. So today we're going to move on now to some of the innovations that we have in plastic bonding. And our big innovation is that we have moved away from a stabilizer called hydroquinone, which has been reclassified. And so to minimize the health and safety statements on the SDS, we've moved away from it. And you can see on these products here, you'll see a label saying HQ and a cross through it, which means it no longer has hydroquinone in the formulation. Thanks. Thanks, George. So hydroquinone, as I've just said, is a stabilizer. It's been reclassified so that it is now a CMR. That is a carcinogenic, mutagenic, reprotoxic substance. And it was used in a lot of instant adhesives or cyanoacrylates as a stabilizer. But we have worked to remove that from our formulations. And you can see the list there of the formulations where we've removed it. And that means that we've improved our SDS without affecting the performance of the product. And on the next slide, summary of the adhesives where we have removed hydroquinone. And you will see a lot of products that you recognise there, but you'll also see our new ultra performance grade 402. And I'm going to hand over to Hakan now, who's going to highlight some of the applications we have where hydroquinone-free formulation has been important or where we've needed 402.
Hi all. As Julie said, I'm going to start with some applications for our instant adhesives. And since instant adhesive provide very fast fixturing and high strength on a wide range of substrates when it's used in the thin bond line, they are very good on bonding, for example, plastics. They are suitable for small parts bonding and can be applied manually directly from a bottle for smaller series or repair jobs, as well as be integrated into automated production lines for larger series. So in cosmetics, a wide range of materials, such as different plastics, metals, and natural materials are joined. And here, Loctite 401 could be a very good choice, thanks to its good substrate versatility. If you're bonding mainly plastics, Loctite 406 could be an even better choice, since it's designed mainly for plastics. And together with this primer, Loctite 770, it can also bond hard-to-bond plastic and elastomers, such as polyethylene, polypropylene, PTFE, and also silicones. Another application area would be handheld devices, such as this remote control. It's made of two plastic parts that are bonded together, and a pad of TPE is also bonded into one of the plastic parts. Here, Loctite 460 is chosen thanks to its very good adhesion to the substrates, fast fixturing, as well as it's a low blooming grade, meaning it will reduce the risk of visible adhesive close to the bond area. Now I'm going to introduce Loctite 402, our new ultra-performance instant adhesive that will offer the performance of a traditional instant adhesive, such as speed, substrate versatility, and strength, but adding to that the performance of being very impact resistant, having higher temperature resistance, and superior heat aging. Now there is a video showing how Loctite 402 can improve your production.
It's an instant world. And in your world, milliseconds matter. When challenges arise, like slow assembly, complex fasteners, and unreliable methods, you need to recalibrate. And Loctite is here to help. Introducing Loctite 402. The ultra-performance instant adhesive. Fast fixture speed, superior heat aging, substrate versatility. Loctite adhesives, cleaners, and automated solutions. Increasing productivity, improving reliability, and simplifying design. All in an instant.
So what would be typical application areas for this new Loctite 402? I would say it would be where you want to use an instant adhesive, but you have not been able to do it previously because of lacking some performance. But thanks to the added performance of Loctite 402, we can now solve this application. The electrical scooter, it's the floor pad, but it's bonded to the housing. And this is traditionally done with mechanical fasteners such as screws, hooks, or clips, and sometimes also tape. Here, Loctite 402 will add faster fixturing, easier to automate, and it will also seal with bond line, of course. And since it's impact resistant, it will also not crack when you hit into something. Nameplates and identification tags of heavy equipment that maybe generates heat or working in a hot environment is also a possible application. This is traditionally done with rivets or screws, but since that includes drilling holes into the equipment, it will also increase the risk of corrosion. If you wanted to bond this before, you had to use a high temperature resistant technologies such as silicones or high temperature epoxies. Loctite 402 will offer faster fixturing. It's less messy. Sometimes you have to, like when an epoxy is normally a two-part product that you have to mix, but you don't have to do that with Loctite 402. And it will resist the temperature and since it's very good heat aging properties, it will also resist the environment for more than 20 years, the lifetime of the equipment. A third application area would be replacing all other instant adhesives in your toolbox, since it will do everything the traditional instant adhesive does, but adding performance of, like we said, in impact resistance, high temperature resistance, superior heat aging, as well as it's a CMR-free formulation. Another technology that will offer instant fixturing is the light curing adhesives. They have a benefit that they will only cure when exposed to the correct light. That means that you will have unlimited time to adjust your parts, and when you are satisfied, you just turn the light on and it will cure immediately. Since it needs to be exposed to the light, you need to have at least one of the substrate that is transparent, of course. There are products that are designed for bonding glass, and there are also products, of course, designed for bonding plastics. Many of them are medical device approved, so they can be used in the medical device industry. And also, since they are very fast curing, you will be able to do the quality control directly after the bonding process. There are also some grades that are available that are flexible, so you can use them on elastomers and TPs, for example, as long as they are transparent, of course. If you can't expose the complete bond area for the light, you can also use a dual cure product. That means they cure with light where they are exposed to it, but they will cure with another mechanism in shadow areas, such as an instant adhesive. There are also other technologies that you can use for bonding plastics if you don't have a need for instant fixturing, such as silicones that will offer a highly flexible bond line and superior high temperature resistance with grades resisting more than 300 degrees. Epoxies will be very strong products and have superior chemical resistance, as well as they are very good on bonding fiber reinforced plastics. The acrylics is also, like epoxies, a family of structural adhesive. They show very good adhesion to most plastics. And this specific grade, Loctite AA3038, is a special product that will bond also hard to bond plastics without using a primer. Since it's a two-component product, it's also gap filling. The hybrids is a quite new family of adhesive where we have combined an instant adhesive with a structural adhesive such as an acrylic or an epoxy. This will also add the benefits of both chemistries, instant fixturing from the instant adhesive and also very good adhesion to most plastics. From the structural side, it will add chemical resistance, humidity resistance, and impact resistance. Of course, you also have some equipment for our adhesive, both for dispensing adhesives and curing our light curing adhesives. Here is a selection of equipment, starting with a peristaltic dispenser on the top. It's an equipment where you put your feed line directly into the bottle of adhesive, and then the adhesive is pumped to the dispensing needle or dispensing pen. Here you can set the speed of the pump, and you can also set the dispensing time. Since it doesn't need any compressed air, it's possible to use almost everywhere. The digital syringe dispenser is a semi-automatic product or equipment that are suitable for our products that are delivered in syringes, like most of our light curing adhesives. Here you can set the air pressure and dispensing time. You will get the same drop size every time you push the button. You can also use it in continuous mode. The RC50 is also a semi-automatic dispenser from our new equipment line. And here you put the bottle into the pressurized container, and then you can attach two separate dispensing valves to this equipment and steer them independently. For curing light curing adhesives, we both have LED equipment and mercury lamps. Here is LED equipment from our new equipment line as well, the CL40. It's LED spot curing equipment. It can control 4 different LED heads regarding exposure time and intensity. You can also choose from different wavelengths depending on which adhesive you're using.
Thank you very much, Julie and Hakan. We will now have some time for a short Q&A session. If any of your questions are not answered at this time, please send an email to the technical hotline or phone us using the number on screen. Thank you.
Thanks, everyone. So we've had some general questions here, which we thought we would raise. We've got, what are the benefits of instant bonding? So that the benefits of using an instant adhesive are that you get very rapid bond strength buildup, you get a virtually instant bond, you get very good, strong bond strengths. And as we mentioned, you can bond lots of different substrates different thicknesses, and you can also accurately dispense using equipment, and you get very neat bond lines. So another question is, what can I do if the bonding time is too short? So we've got a range of instant adhesives which have got various fixture times. So we should have something in our range to be able to help with this problem. Please contact us on the email address that you can see on the screen. So technical service, all one word, .loctite@henkel.com, or give us a call on 01442 278 100 and option 4. We've also got a question asking us if we can have some more technical information on 402. So there is some further information available on our website, which is henkel-adhesives.com, or you can contact us on the email address or the telephone number. And then finally, how can I bond difficult to bond plastics? So by that, I guess that you mean low surface energy plastics. And if you do have to bond these materials, then you can also use a primer before you use the adhesives. So we offer Loctite 770 to be able to bond difficult plastics. Or alternatively, you could use a plasma treatment before you use the adhesive. So if you do have any further questions, our contact details are on the screen. So it's 01442 278 100 and option 4 if you would like to call us. Or alternatively, you can send us an email, which is technicalservice, all one word, .loctite@henkel.com. Thank you, everyone.
Thank you.